Okay, let's move on to the next part of this section, and we're going to have a few definitions here and then do some identifying. So our very first item to define, and we're going to sketch a picture, is what is a transversal. So a transversal is a line that intersects two or more coplanar lines at different points. So I'm going to draw two lines. They could be parallel, but they don't need to be. So I'm going to draw them to not be parallel. So let's draw one line here, and I'll maybe angle this one here. Okay. Now my transversal is going to have to come through more vertically because it's a third line that intersects these two coplanar lines at different points. So maybe like this. Okay, so this is my transversal. Okay. So now we've got angles that are formed. See how I have 4 angles here and I have 4 more here. So let's number those angles. So I'm going to go with 1, 2, 3, 4. And then I'll do the same thing down here. 5, 6, 7, 8. All right, so I will have 8 angles that are formed. These angles have particular names that go with other angles. So we're going to link together pairs of angles from this group of 4 at the top to this group of 4 at the bottom. So that's what this bottom section is about. When two lines are cut by a transversal, so these two lines are cut by a transversal, two angles are corresponding angles if they have corresponding positions. So for example, angle 1 is in the upper left region of this 4, and angle 5 is similarly in the upper left region of this 4. So these are called corresponding angles. So we actually have 4 sets. So I'm going to list them right here. So I'm going to use the angle symbol. So angle 1 and then comma angle 5. All right, that's one set of corresponding angles. Angle 2 over here is corresponding to angle 6. Angle 2 and angle 6, that's a second pair. Angle 3 and angle 7 are in corresponding positions. Angle 3 and angle 7. And then the final one would be angle 4 and angle 8. Okay, so it's kind of like the same general location, but along different intersections of that transversal. All right, so that's one of them. So corresponding angles, these are names you need to be able to recognize and write down. Okay, another set. When two lines are cut by a transversal, two angles are alternate interior angles if they lie between the two lines and on opposite sides of the transversal. Okay, so I think of alternate, so on opposite sides of the transversal. Interior, I want it to be in between the two lines. So 4, 3, 5, and 6, I would consider those interior. So I have 2 pairs of alternate interior, angle 4 and angle 6. They're on opposite sides of the transversal, but they're in between the lines. And then angles 3 and 5 are the other set. Angle 4 and angle 6, angle 3 and angle 5. Okay, so they're alternate interior angles. They alternate the transversal, but they're in between the two lines. Okay, next is alternate exterior. When two lines are cut by a transversal, two angles are alternate exterior if they lie outside the two lines and on opposite sides of the transversal. So it still alternates the transversal, but it's above the line or below the line. So I've got 1 and 7. They're on the outside part of the lines, and they're back and forth on the transversal. 2 and 8 are the other pair. Angle 1 and angle 7. Angle 2 and angle 8. Alternate exterior angles. All right, we just have one more set that we're going to identify, and they're called consecutive interior angles. So when two lines are cut by a transversal, two angles are consecutive interior angles if they lie between the two lines, so there's the interior part, and on the same side of the transversal. So 4 and 5 are considered consecutive interior. Okay, they're along the same side of the transversal, they're in between the lines, and so are 3 and 6. All right, so we have angle 4 and angle 5. angles 3 and 6. Okay, and then those are called consecutive interior angles. So a lot of what we're going to do here today, and really the next several sections, is we need to know what these are called, because we're then going to link theorems with these particular angles. Okay, well, let's move on and do some examples here. Okay, number 2 here at the top. Identify angle relationships. So let's identify all pairs of angles of the given type. All right, so corresponding, you are on the different lines, but in the same general area. So 1 and 3 are corresponding. So angle 1 and angle 3. And this is the only set where there are 4. 1 and 3. 8 goes with 6. Okay, angle 8 and angle 6 are a set. We've got 2 and 4. Okay, 2 and 4 are corresponding. And that leaves 7 and 5 as the final set. Okay, now if you want to pause this and try these on your own, that's fine. I'll just kind of talk through them. Alternate interior, opposite sides of transversal in between the lines. So 2 and 6, 7 and 3. Angle 2 and angle 6, angle 7 and angle 3. Okay, alternate exterior, alternating outside the lines. 1 and 5, 8 and 4. Angle 1, angle 5, angle 8 and 4. And then that leaves consecutive interior, so same side of the transversal, 2 and 3, in between the lines. 7 and 6. Angle 2, angle 3, angle 7, and angle 6. Okay. Well, I would like you to actually go ahead do this next example. So if you didn't pause on the first set, go ahead and pause here, and you are filling in the blank here with one of the sets of 4 new terms we're talking about. Okay, we've got alternate interior for number 5, corresponding, alternate exterior, and the last group is consecutive interior. All right, we have a couple things at the end, but what I want to do is throw a little bit of a challenge at you. So this picture is a little bit different in that you've got intersecting lines, many intersecting lines, and different transversals. So we can still identify if we have a set of corresponding or alternate interior, even if the lines intersect. So I want you to try to pause the video, identify which line, okay, for example A, look at angles 1 and 3. Which line is the transversal for 1 and 3, and then what are they classified by? Are they corresponding? Are they consecutive interior? So go ahead and pause here and let's see what you can come up with. Okay, for 1 and 3. So when I'm looking at 1 and 3, the transversal is the line that 1 and 3 come in contact with. So line L right here, I think that's a cursive L. Line L is your transversal. So if you kind of turn the page to take a look at it, so number 3 is in this group of 4 angles here, so it's kind of on the lower right. And when I look at angle 1, it's also in the lower right. So these are corresponding angles for that group, first group. And I'm just going to abbreviate here a little bit, CORR for corresponding. Letter B, 2 and 6. So 2 and 6, the only line that connects, that 2 and 6 both touch is line N right here. So that is your transversal. So 2 and 6, if this is my transversal, see how they're alternating that transversal. So it's either alternate interior or alternate exterior. So if you wanted to resketch these and straighten these lines up a little bit, you could do that. Okay, so let's just say, let me resketch this top line. Let's say I start here, and then let's make my transversal so that I have just resketched 1 and 2 right here. So let's say I can take line M and go like this and straighten it out some. So if I've done that, see how 6 is on the left and 5 is on the right? Well, 6 should still be on the left and 5 should still be on the right. So if I sketch it where I straighten a line out, now I can easily see 2 and 6 are alternate interior. Okay, you can still probably maybe see that they're inside those 2 lines there. But this is a technique you could do to help you figure out what some of those are. Alternate interior. So if you want to pause and try that on the last 2, you can. Okay, we've got transversal is M, and those are alternate exterior, and our transversal here is N, they're consecutive interior. Okay, so those are definitely challenging ones. We'll just do a little bit of questions like that. All right, we have just 2 more items to look at here. We have a couple postulates that are kind of basic. You could sort of reason through them, but let me read through them with you and have you sketch a picture. So the first one is called the parallel postulate. And what it says is, if there is a line and a point not on the line. So let's pause and draw that. So sketch yourself a line, maybe something like this. So here's my line. Let's just say that's line L. And there's a point that's not anywhere on this line. So let's just put that up here. I don't know, I'll call it point A. All right, so if there's a line and a point not on the line, the parallel postulate says, then there is exactly one line that is through this point that is parallel to the given line. So it's saying there's only one line that can go through that point to remain parallel, which that should hopefully make sense, but it's called the parallel postulate. Okay, so if I were to draw a line through here, I could really only draw it in one direction in order to make these 2 stay parallel, okay? The perpendicular postulate is the exact same idea, only we have a perpendicular line. So if there is a line and a point not on that line, so same idea, line, point not on the line, then there is exactly one line through this point that is perpendicular to the given line. So there's really only one line we could draw through here to be perpendicular. And so they seem kind of basic that, well, obviously that makes sense, but those are the building blocks of parallel and perpendicular. So it's called parallel postulate and perpendicular postulate. Okay, that wraps up this first section. If you have any questions, feel free to reach out to me.